Hey everybody, my name is Aidan Finn, and today I'm going to talk to you about using Azure Firewall in the real world. I'm a 13-year Microsoft valuable professional. Currently, my expertise is with Microsoft Azure, and previously I've had the expertise of Hyper-V or System Center Configuration Manager. I own my own company called Cloud Mechanix, where I have been developing and delivering my own custom-written Azure training in Europe and the UK. In the day, I work as a principal consultant for a company called Innofactor. I work for the office in Oslo, Norway, and I work with Azure infrastructure, specializing in security and governance stuff. I've been working in IT since '96, you name it. I've been at technical sales, consultant, sysadmin, worked in hosting, finance, consulting, etc. And I've worked with stuff such as Windows Server, Hyper-V, System Center, yada, yada, yada. You can find me blogging on aidanfinn.com. You can learn more about my employers in a factor on innofactor.com, and you can learn about my business, Cloud Mechanix, on cloudmechanics.com. And of course, you can follow me on Twitter, where I am at Joe_Elway. So, why do you need a firewall? Surely you don't need a firewall these days in the cloud because they take care of all of that stuff for you. Well, if you go around and look at the news, these aren't really Hyper-V stories, but they are just general stories that talk about how we've been architecting our data centers. Well, it lets you know that we haven't really done a good job at doing network security in data centers. We focused on, hey, let's just put this hard secure edge up there and everything will be good inside of that edge. Once you get inside of our WAN, hey, everything's good. Norsk Hydro, an aluminium manufacturer in Norway, they found that that isn't true to the tune of $40 million. And of course, the UK a few years ago, they found out, thanks to WannaCry, that that sort of approach isn't good to the tune of £92 million and counting, probably. Um, so you've really got to implement security properly, and it's important that you have the right people doing that job. And Microsoft, well, they can give you a good story too of the wrong people implementing security. And this is actually a cloud story where data was put into a database and the developer accidentally opened up the firewall rules to let anyone on the internet connect to that database. So this is the old classic problem of the cloud where everybody can do whatever they want. The problem is everyone can do whatever they want, and they aren't necessarily good. You think your typical dev, what are they going to do? They're going to get their data accessible, they're going to get their application working. Security, yeah, that's kind of secondary because it slows them down from doing their job. So the whole classic approach of I'll throw up a network security group or use the firewall that's in the database server, the storage account, and that'll be enough. It's not going to do the job because the wrong people are doing network security. And they're doing it in, well, it's one of the right places, but there needs to be a central place where central IT people or central security people can do the right job and manage it and monitor it as well. So that's what we need to do. We need to implement something that classic network security should have done but didn't. If you look at the classic data center, as I said, once you get in through that edge firewall, everything's open. So that's the north-south problem. They've implemented security at the edge, but they haven't continued to implement it throughout the entire system. So this is where we have to implement micro-segmentation. And what you'll typically find in your classic data center or your WAN is, hey, we'll put that firewall on and we'll disable Windows Firewall. Well, that's not micro-segmentation. Um, Micro-segmentation is, yes, we have that edge firewall, but we implement firewalls throughout the entire network. And if you want to get from A to B, you have to pass through at least one firewall, possibly two, maybe even three, including the guest OS. So in this particular Azure depiction, we have the security officer, and her job is to manage that central firewall. Anything going in or out of the environment, or even east or west through that environment, must go through that firewall that she manages. Of course, the developers and the operators still control network security groups and firewalls and their resources. And of course, you can use Azure Policy to harden some of that stuff too if you want to centralize the management of that. Um, and this is the approach that we should be implementing in the cloud. So let's talk about Azure Firewall. And surely you're not going to tell me to use a firewall made by Microsoft. You have to be insane, right? You remember stuff like Forefront, Internet Security and Acceleration Server ABCDEFG. Um, yeah, I do, and it was actually pretty good. I did use it, and I found it to be quite a good product if it did end up dying. Um, But if you want to see my serious answer about this, well, it's a deadly serious answer. I do use the Azure Firewall with my customers. I use it with every single one of my customers. And I am being deadly serious about this. This is super technology. The focus is implement the security, not the appliance. It's a platform first approach, which is what my customers like. And they don't want to be managing stuff. They want to implement their services and they want to secure their services. And everything outside of that is a distraction. They've realized what IT should be doing. It should be serving the business, not looking at cool flashing lights in a dark room and going, hey, Mr. Salesperson from a firewall company, take me out to dinner again. That's not the function of IT. So the Azure Firewall, as I said, it's a platform resource. It's a function in the platform, so we can turn it on and just start using it. There's no maintenance, there's no upgrades. It's a single vendor, so if I have an issue with my network security or my network functionality, I go to Microsoft support and I say, hey, I have a problem, you deal with it. Instead of going, well, Microsoft, I've got a problem with my third-party firewall, and they're pointing the finger at you, and they're saying there's something wrong with the networking in Azure and it doesn't work right, and you're saying there's something wrong with their appliance, and well, you can see where that's going to go. It's not going to end well. This firewall, it's an ARM resource, so typical Azure resource, Azure Resource Manager. Um, and that means that it's deployed using ARM and it's maintained using ARM. Well, it can be. You can also do the clickety-click thing in the Azure portal, but you're really losing one of the key features of this platform approach to the firewall, which is we can implement the configuration of the features, and we can implement the rules as code. This means they can be sitting in a GitHub repo or a DevOps repo, and we can have change control. That code is now our documentation, so there's no need to maintain a spreadsheet or a Word document to explain what every single rule is. It's there in the code. And every time there's a change to that, someone's got to review it, got to do a pull request and a merge, and then that gets pushed out via a pipeline. Of course, there's a problem with the code, you can do a rollback. And your documentation is your backup. So if something happens to that firewall, or if you need to re-implement that firewall somewhere else, or whatever it is, or clone it to create a new data center, that's easy to do because you just rerun your code. This is the real benefit of doing your DevOps, or if you want to call it DevSecOps approach to firewall management. There are two types of deployment to the Azure Firewall. The first is the VNet approach. This is a more regular approach to the Azure Firewall that you may be familiar with. So instead of deploying your NVA in a firewall or in a virtual network or a subnet in a virtual network, you're going to deploy the Azure Firewall into your regular virtual network. And this could be a single virtual network for a point solution or a small medium business, or it could be deployed into a hub in a much larger enterprise hub and spoke architecture. But if you're doing a hub and spoke architecture in your modern enterprise, you might be doing SD-WAN, and if that's the case, you might be implementing Azure Virtual WAN with one of its 15 or so partner appliances. If that's the case, and you are implementing the Azure Firewall, the way to do that is implement what's called a secure virtual hub. And this is where the firewall is implemented as part of that appliance-style hub. The hub itself is a hidden resource. And the VNet itself, actually, you can't even see the VNet. There's some clues to it if you look at peering connections from your spokes, but it's running in a Microsoft tenant. It's not in your tenant. So it's effectively a Microsoft Azure managed app. And that's a different SKU of the Azure Firewall. Same pricing, same features, same structures. It's just it's deployed differently because you can't see the virtual network in that case. So the virtual network itself will have a dedicated subnet, and we're going to talk about a second possible subnet later on. But typically, you're only going to have one dedicated subnet, and it must be called Azure Firewall Subnet. Routing from the firewall is dictated by the routes that that subnet happens to have. So whether it's routes that are propagated from BGP via your virtual network gateway, or it's system routes that are there because of things like peering connections, or you've added user-defined routes, they're going to be implemented. Now we're going to talk about something, a complication with non-RFC 1918 addresses later on, how those routes won't actually apply in that case. And speaking of routing, it amazes me when I'm talking to people, especially it's a classic interview question for me now. If someone says they work with firewalls in Azure, I'll always ask them about routing. And I'll ask them how do they get their traffic into to the network through the firewall, and how they get traffic out of their spokes or their subnets to the rest of the world through the firewall. And I'm expecting them to talk about user-defined routes. So they should have user-defined routes in the gateway subnet to force ingress traffic from on-prem through the firewall to get to the other subnets behind the firewall, or the peered spokes. And they must have user-defined routes in the spokes or the rest of the subnets that are behind the firewall to get out to the rest of the world. And when you're doing that sort of thing, you also need to make sure that you put in your overrides for your platform control plane. So things like app service environment or SQL MI or API management can't do their control plane traffic through the firewall. They've actually got to go to quote unquote internet. So under the covers, when we deploy one of these firewalls, well, if you look in the Azure portal, you're going to see this lovely little icon of a firewall. And under the covers, there's a whole lot of stuff actually going on. So that firewall, it's going to have a visible public IP address, actually up to 250 public IP addresses. We'll come back to that later on. And it's going to have a single private IP address. That's that private IP address that you're going to route to force traffic through your firewall. Under the covers, this is actually a number of virtual machines that are load balanced using the standard tier Azure load balancer. And this gives you automated scale out and high availability. So this includes the ability to deploy across availability zones if your Azure region happens to support availability zones. And with that, you'll get a 99.99% SLA. If your Azure region does not have availability zones or you choose not to take advantage of that, you'll have a 99.95% SLA. So just a slight drop. The firewall will automatically scale out, and that increases its cost automatically. It's built into the billing of the utilization, and that will scale out to support up to 30 gigabits per second of throughput. Now you can go beyond that with a support call up to 40 gigabits per second. And that's quite a lot, and it's way more than your typical virtual appliance will actually be able to handle. And you don't need to buy any licensing or do any of that stuff or muck about with service bus or duplicate any configurations or rules or whatever. It just automatically handles all that stuff for you because it's a true platform service. The resources, well, you have an Azure Firewall. Now it happens to have a public IP address that you'll have to associate with that Azure Firewall. And that firewall will have inside of it stuff. So it will have features, so we'll talk about those, they'll need to be configured. And then it's going to have rules which are aggregated into these things called rules collections. And our admin, she can manage that through the Azure portal or through ARM templates or whatever third-party IAC solution she wants to use. And if we have a second firewall, well, that's a second appliance. And this is the classic administrative model. So there's double the effort here. But thanks to a new feature called Azure Firewall Manager, we can take advantage of something called firewall policy. And instead of directly managing the firewall, we now manage the firewall policy, which is associated with the firewall. So now my firewall admin, he's been a smart guy and he's gone, right, I'm using this firewall policy because I know this is the future of Azure Firewall and I'm going to manage my features. Now my rules groups, which group rules collections. And rules collections contain my different types of rules, which we'll talk about in a few minutes. And of course, if we have a larger enterprise, now our central firewall admin, she's able to create a parent policy, which is inherited to child policies. And those child policies are then associated with firewalls. So our central security officer, she has the job of saying, right, these are the features that must be enabled and configured in my firewalls. And these are the settings those features must have. And I'm going to dictate some rules to the rest of the organization. And no matter what happens, my rules will always be applied. Now my local admin can go along and go, right, I want to create a policy that I will associate with my firewall. I will inherit from the parent because that's how I have to do my job to be approved. And anything that she dictates in the parent policy will be enforced immediately. As soon as she clicks commit or save, it will appear in that child policy and therefore, through the association with the firewall, immediately into the firewall. This gives us a nested approach now. So central admin, she can focus on the company-wide stuff or the inter data center type stuff, and the local admin can just focus on the services that they are responsible for. So now we're to the point where we want to talk about rules. Important to know that the Azure Firewall, its core function is to filter traffic, allow or deny traffic, and all traffic is denied by default. All traffic, inbound, outbound, doesn't matter what kind of traffic it is denied by default. Unless you explicitly allow it, it won't be allowed. And that includes, hey, I've deployed Windows Virtual Desktop and it's sitting behind my Azure Firewall and I want to stop people from browsing the internet because I'm implementing this the concept of a secure zone with secured applications and I don't want data to leak. Well, if you don't allow them to browse the internet, they will not be able to browse the internet. If you don't allow them to access specific URIs, they won't be able to browse those URIs because everything is denied by default. We have three kinds of rules. We have network rules, and these control the inbound or outbound flow of traffic to or from IP addresses. And there's a preview feature there to support fully qualified domain names that resolve to an IP address. Application rules deal with HTTP, HTTPS, or Microsoft SQL Server, and that includes Azure SQL and Azure SQL Data Warehouse traffic. And this is for outbound flows only. So if I am sitting on a Windows Virtual Desktop device hosted in Azure behind an Azure Firewall and I want to browse to bing.com, unless there's a rule to allow me access to bing.com, an application rule, I will not be able to get to it. And then finally, we have DNAT rules. And this is where we want to expose some service that's running behind the firewall to the internet via a public IP address associated with that firewall. Now, it's important to note that this isn't web application firewall stuff. Today, if you want to do a web application firewall on Azure and you want to use a platform for that, you'll use the web application firewall feature, which is associated with the Azure front door or with web application gateway. DNAT rules, when you create them, they will implicitly create a network rule. It doesn't actually create a rule that you can see, but it does implicitly create a network rule, and it actually logs as a network rule as well. These rules now aggregated into collections. So I can create rules collections for DNAT rules, I can create rules collections for network rules, I can create rules collections for application rules. And there are two core properties in here other than the name. The action, so whether the rules that are listed, so the filters that match traffic, sources, destinations, ports, protocols, and all that stuff, whether we want all the rules to either deny the traffic or allow the traffic. And then we can use priority, so we can stack these rules collections. Higher priority rules collections get processed first, and therefore their rules are processed first. Lower priority rules collections processed later, and therefore their rules are processed later. And the first matching rule that matches the packet that's trying to flow through the firewall is the rule that applies. Now, we get into processing order. And the processing order depends on whether the traffic is coming in or it is going out. And remember, the first matching rule applies. So if the traffic is coming into the firewall, if it comes in via the public IP address, it will be processed first by the DNAT rules. And if there's a matching DNAT rule, well, the traffic will be allowed in. Now, there's an asterisk on that. After that, we have network rules. Now, any traffic trying to go east or west will be processed by network rules as well if it hasn't been allowed already by a DNAT rule. So network rules, as I said, are going to deal with source IP addresses or destination IP addresses as well. But if a network rule has an identical configuration to a DNAT rule but denies the traffic instead of allowing it, then any DNAT rule that allowed that traffic will be overridden by the network rule. So it's basically the network rule. As I said, they're the hard-coded rules, and DNAT rules are just implied network rules. So if there's an explicit network rule that denies that traffic, it wins. If your traffic is leaving to go out through the Azure Firewall and out to the rest of the world, so on premises via ExpressRoute or site-to-site VPN or out through the internet, then the order is network rules first, then application rules, but only if the traffic is HTTP, HTTPS, or Microsoft SQL Server. Now we get on to the Azure Firewall features. It's a growing set of features in the Azure Firewall. The first thing I want to talk about is IP groups, which is not really a feature of the Azure Firewall, but the Azure Firewall supports these kinds of resources. And an IP group is a resource that we can create that abstracts one or more IP addresses or CIDRs. So instead of us constantly putting these addresses into our firewall rules in the Azure Firewall policy or in the Azure Firewall, we just reference the IP group instead. This is easier for us to read, Once we define an IP group, we can reuse it over and over again. And it also means that if there's changes to our network, if we've abstracted those address ranges that we're creating rules for using the IP groups, all we've got to do is change the IP group instead of going around and changing all of the rules. And as soon as we save the IP group, the associated rules in the firewall will be updated. We also have support for tags. So there's two types of tags that we can implement in the Azure Firewall rules. First is service tags. And this is where Azure services, which are normally addressed using an IP address, are instead addressed using a service tag. So instead of having to know all the IP addresses of all the storage clusters in all the Azure regions, we can just put down azure.storage. And it's just a simpler way of saying, hey, I want to allow or deny traffic to Azure Storage. We have a similar thing for FQDN tags, which is where Microsoft Cloud services are abstracted. So instead of needing to know all the fully qualified domain names to access Windows Update, we just say, yeah, we want to allow Windows Update. We want to allow those outbound HTTP or HTTPS connections. And we don't need to worry about all the possible different URIs that Microsoft might use for that particular service. Cool feature in the Azure Firewall is threat intelligence. And this is where we may have rules that allow traffic, but those rules might be misused by the bad guys. And I should say bad guys in air quotes here. Databases are maintained out on the internet that track known bad IP addresses or malicious IP addresses. And Microsoft do this using the Microsoft Intelligence Security Graph. Now, even if a rule happens to allow a connection to or from that IP address, threat intelligence can kick in and do something. So by default, it's disabled, but we can set it to alert only. So it'll record in the logging that there was a connection, a successful connection to or from a malicious IP address. But we can also implement alert and deny. And this is where even if a rule allows saying, hey, allow that outbound connection to that web server, even though we know through threat intelligence that it's a bad web server, deny it. Don't let it happen because we know it's a bad IP address. But there's a problem with this sort of thing, and that's where we get false positives. So a common example I come across is I have some service that's trying to connect to a web server, and that web server once hosted a piece of malware, and it's been tagged as a malicious IP address. And the example is OneDrive for Business, where some service is trying to connect to OneDrive, and that one physical OneDrive server or abstracted OneDrive server behind that IP address had some malware on it once, and now it's a bad server. Well, I need to allow that connection because there's something required. And I often see this with third-party CDNs as well, where, for example, a Ubuntu virtual machine is trying to download up updates for itself, and it's going through through a CDN, and that CDN has been known to cache malware through no fault of its own. Some web service that was using it was infected. So what we've got to do is override that that automated deny rule. And we can do that using a feature in the Azure Firewall policy called Threat Intelligence Whitelist. So we can say, hey, that IP address that's been logged through the alerting, let's take that and we'll put it in the whitelist to say, right, don't block that. We know it's a good IP address. We've done the lookups, we've done the whois checks, and it's a valid IP address. So don't block it. One that I've encountered actually in a university scenario and in the public sector is where we have clients who are using public IP address ranges privately on their WAN. And they've done this because, well, some of these organizations were some of the first on the internet. And they haven't really got widespread use of what we call RFC 1918 addresses. So these are the addresses we typically are deploying in modern networks as our private IP address ranges, so the 192.168s, 172.16s, and the 10s. These other organizations are using their huge blocks of public IP addresses on their WAN. Now, it's not like they're routed to the internet or anything, it's just they use them as their private IP addresses. And this causes us a problem with the Azure Firewall because let's say I have a service running in Azure, it's protected by the Azure Firewall, and it wants to communicate with a client or a service that's running on-prem on one of these non-RFC 19 addresses. Well, it's not going to be able to, because the default action of the Azure Firewall is if a packet comes from a protected network to the Azure Firewall and it says, hey, go to this public IP address of 212.88.4.1, and yeah, you should route that over my express route or over my site-to-site VPN. The Azure Firewall is just going to go, no, public IP address, that goes to the internet. And that's the default behavior of the Azure Firewall. So instead of that, what we can do since January of this year is we can enable non-RFC 1918 addresses to be routed privately. So we can configure a feature called network.snet.private ranges, and we can do this through the Azure portal, we can do it through PowerShell, we can do it through JSON, and we can say, hey, yeah, we want to continue to route IANA private ranges, so our 192.168s, our 172.16s, and our 10s through whatever our default routing is on the Azure Firewall subnet, but we also have other CIDRs or addresses that we want to route privately as well. And that will resolve that particular issue for those organizations that have used non-RFC 19 addresses on their WAN. We have this forced tunneling feature as well. So some organizations have made an investment or maybe have a policy to say that nothing can leave their Azure data centers or Azure footprints or their Azure firewall and go to the internet without going through some sort of specialist network equipment or appliances. So maybe they've got some filtering stuff, or maybe they force everything to go across their express route to go through some sort of appliance on-prem before it goes out to the internet. And by default, the Azure Firewall will not support you doing this because some of its control plane traffic must go directly to internet. So if you want to enable forced tunneling, what you'll do is you will implement the Azure Firewall with a second subnet called Azure Firewall Management Subnet. And this moves the control plane of the Azure Firewall to this new second subnet. Then you'll create a user-defined route on that Azure Firewall Management subnet to say if you want to go to quad 0, you will route directly to internet, and you'll make sure that route propagation is disabled. So if you've got BGP routes propagating from your virtual network gateway subnet, they will not get to the Azure Firewall Management subnet, and they will not break this UDR for the control plane. Then you'll allow your regular propagation or put in your forced route on the Azure Firewall subnet to do your forced tunneling now to this virtual appliance. Right, we've talked about a lot of stuff, and I've mentioned a couple of times now where there's things that we'll just need to be able to monitor and alert on. And the Azure Firewall does generate logs and alerts, it generates a lot of data. There are three types of logs. There's network log, which includes DNAT rules and network rules. We have the application log, which includes our application rules. And we have the threat intelligence log, where if we have alert or alert and deny mode enabled, threat intelligence will log any traffic that is encountered from known malicious IP addresses that are identified in the threat intelligence database. The destinations we can send this data to are storage account, so an Azure storage account, where that data will be stored in blob format using JSON. We have Event Hub, where we want to send this data to third-party appliances or services such as Splunk, for example, or you can send this data to Log Analytics. And this is your searchable database that's in the platform. And to be quite honest, it's the most useful because platform integrates. We also have metrics through Azure Monitor, which can be useful as well. We'll talk about one case where that'll be useful in a moment. So when we have our data in Log Analytics, we can query that data. So if I want to do just straight queries, I can do that, but I could take those queries and I can create workbooks. So these are visualizations or reports. We can also connect directly into Log Analytics using Power BI if you want that sort of experience as well. We can create scheduled query alerts. So this is where we're using Azure Monitor and we're saying, hey, run this query on a frequent basis against my Log Analytics workspace. And if there is something found, do some sort of automated action, so an Azure Monitor action group. So that could be generate an alert by email or SMS or phone in the US, or it could be trigger some webhook or API call or logic app via one of these action groups as well. And then finally, we can integrate Azure Sentinel, Microsoft Security Information and Event Management, or SIEM solution, to our log analytics workspace. And now we can start creating incidents from stuff that's going on inside our firewall. So when threat intelligence is finding stuff, or when there's been too many denies, um, create an incident in Sentinel. And this is where we can now start combining this data with many other different sources, including third-party firewalls, and doing unified entity behavior analysis, or UBA. And tying up not just individual alerts, but tying up sources of data that are keyed on entity data such as IP addresses. Now, public IP addresses. Our Azure Firewall will have one public IP address by default, but we can deploy that Azure Firewall with up to 250 public IP addresses. Now, my tip here is if you are going to deploy the Azure Firewall with more than one IP address, or you might do in the future, reserve a set of consecutive addresses up to 16 using a /28 CIDR using an Azure feature called a public IP prefix. This means that you'll have 16 consecutive addresses instead of dealing with individual addresses which could be from all over the place. And then you can activate and associate those addresses with the firewall as required. Now, having more IP addresses solves two particular problems. The first is the classic DNAT conflict issue. Let's say I've got two FTP servers that want to listen on port TCP21 and through my Azure Firewall. I can only do that with one FTP server if I have only one public IP address. If I want to enable a second FTP server to DNAT through the Azure Firewall, I'm going to need a second public IP address. So that's the first scenario. The second one is where we have the load balancer outbound port constraint issue. And we're going to look at that in a second. Now, if you do have more than one public IP address on your firewall, you will not be able to control which IP address is used for your outbound flows. So that means if there's a remote location that's creating firewall rules to allow traffic from your firewall, you won't be able to say which of the IP addresses they should expect that traffic from. So this is where having consecutive IP addresses will become useful, because you'll be able to say, hey, here's my CIDRs or my CIDR for my firewall. Just allow traffic from that instead of giving them a bunch of random IP addresses. Now back to this port constraint issue. And it's important to note that this is actually not an Azure Firewall issue. This is an issue that affects all network appliances, all network services, including web services or whatever, that are aggregated or made highly available using an Azure load balancer. The load balancer with a single public IP address is limited to 64,000 ports for SNAT, so that's outbound connections. Now, if you're dealing with some bad code, and I've seen this actually in a customer site, where you've got some bad application that's been written a long time ago and the developer really didn't know how to write a good network application, and it's holding on to those connections, those port connections. Those port connections could remain open for between 4 and 120 minutes each. And if there's lots of those connections happening, you'll quickly eat up those 64,000 SNAT ports on the standard load balancer. So the workaround for that is, first, use Azure Monitor metrics and create an alert for the number of SNAT ports that are left on the Azure Firewall. And when there is an alert, go back to your public IP prefix, which I told you earlier on you really should do, and add more public IP addresses to the firewall. So each IP address will add another 64,000 ports. Now you're going to, as I said, you're going to see the exact same issue no matter what brand of firewall you implement. So whether you go Cisco, Checkpoint, Barracuda, whatever, you're still going to have this same issue once you have a highly available firewall. So this is how you actually solve it. So let's get some real world tips before we wrap up. If you are looking at a fresh environment up in Azure and you're implementing a firewall for the first time, be aware that your Cisco person, as I've called them here, is going to fight you. And they are going to want to implement their brand of firewall and whatever the motivations are for that. They're going to tell you that their firewall does more than the Azure firewall, and you know what? There's a chance that's true, but what I have found is it's not often true. Um, the on-prem appliance might do lots more, but the virtual appliance will not because they have constraints on the processor capacity. What they will definitely not be able to match is the throughput of the Azure Firewall. To do that, they're going to require you to buy lots of licensing and configure lots of complicated features like Service Bus to make the thing highly available and to synchronize configurations across the different instances, assuming their brand of firewall is even able to do high availability or synchronized configuration of rules and features. Um, the second problem with their NVA approach is that they're going to be focusing on virtual machines and maintenance and all that stuff. What's your job here? Why are you putting in a firewall? It's because you're trying to put up highly available services and you're trying to secure them. You're not getting into the business of putting up stuff to make some salesperson happy. Your job is to make your business happy. So focus on the configuration of the features and the firewall rules, and that's what the Azure Firewall gives you. It eliminates all the other distractions. Second tip is use Azure Firewall Policy or Azure Firewall Manager. In my opinion, there is no future in managing the Azure Firewall resource directly. We can already see that there's some feature disparity here. So the Azure Firewall Policy is getting new features that the Azure Firewall is not. And we can see that with the Threat Intelligence whitelist. Day zero, implement your logging to log analytics. Even if you are going to be using some third-party thing via Event Hub, um, use the data in log analytics, even if you're only going to keep that data for 30 days. Because that data is going to be there, it's going to be there quickly, and you're going to be able to query it. And a lot of the technologies that are in Azure are built to find that data in log analytics. So implement that logging to log analytics, play with the logs, play with the data, get to understand what it is to search those logs and to find things that are being denied or allowed. Build your queries. You know, there's some samples in there in log analytics already. You can find them also on Microsoft Doc site. And build your own workbooks. And Azure Firewall have even provided a workbook at this point. And you can build your own versions of those workbooks to do your troubleshooting instead of doing it through the log analytics query interface. This data is going to be critical to you. Whether you're troubleshooting, and not just the firewall, but also troubleshooting your site-to-site VPN, your express route, whatever, validating that the traffic is actually reaching the firewall. Whether it's being allowed or denied, that's secondary. Is it even reaching there? You'd be amazed how often you're going to go to the firewall logs first to start investigating networking and connectivity and service level issues. And then when you're getting more mature with this, start creating alerts. So create alerts for excessive numbers of denies. Create metrics alerts for that SNAT port utilization. If you're using the threat intelligence feature, create alerts to let you know when there's a deny. So you can go and investigate that as quickly as possible to see if it's a false positive. And if it is, then you can implement a whitelist entry or add a whitelist entry in your Azure Firewall policy. So that's it. That's the Azure Firewall. That's my experience from the real world. Um, I hope you've enjoyed this session, and I hope you enjoy the rest of the sessions from this rather unique festival event, and have a great holiday, whatever it is you are celebrating this winter. Bye.